Hi guys, in this video we are going to take a look at computing line integrals of type ds. So ds integrals are integrals with respect to arc length, and they are a type of what they call line integral, which is really an integral over a curve. So I don't know why they're called line integrals, they should be called curve integrals, but I can't decide that. So anyway, how do we compute them? So one of the most common mistakes that I see is people think that ds is automatically just dt, and that is not true. So there is a formula for ds that is like a small change in arc length or length of a curve. So if you think about it, like if you draw a little piece of a curve, right? And so this piece is going to be your ds, a change in length of s. But if you approximate it by a straight line segment, then if you think of this as dx and this is dy, then you can see that from the Pythagorean theorem, dx squared plus dy squared is the same as ds squared. So I just wanted to give you an idea why that's the case before I actually give you the formula. Now, this formula would be for 3 dimensions, so we'll have an extra term, but dx is really x prime multiplied by dt. So the dt we always write at the end. So this is just going to be x prime squared plus y prime squared plus z prime squared, and then the whole thing is multiplied by dt. So very important to note that ds is not dt, that there is an extra term here. However, that term can be simplified. So how do we simplify that? Well, first you have to compute the derivative. So first you have to find r prime. Now, r prime is just found by taking the derivative of each component and remembering that whenever we differentiate cosine, we get negative, right? So this will be negative. 2 will jump out in the front and give us 14. And then this will be sine 2t. The next one will be positive, right? So 7 times 2 is 14 cosine 2t. And then, of course, the derivative of 5t is just 5. So we found the derivative. Now we're going to square each component. So 14 will be squared. The negative right here doesn't matter because when you square a negative, that becomes a positive. So that will be 14 squared sine squared. And then we add 14 squared cosine squared. And then we also will add 5 squared. Now, one favorite trick here is to notice that 14 squared from the first two terms can be factored out, and what will be left? So you should be able to notice that we got that sine squared plus cosine squared, which is really 1. Right? This is that first trigonometric identity, so that's just going to be 1. And so this ds actually simplifies very nicely. Now, if you're wondering, what about that 2t? Does it matter that it's 2t? Will it become 2 or something like that? The answer is no, no. As long as the argument here is the same, so it's 2t, it could be anything, as long as they're the same, sine squared plus cosine squared will always be 1. So if we can compute 14 squared and 5 squared, that's going to be 221. Whoops. Okay, so this will be 221. Now, that would be under the square root. So if they're asking you what is ds, that should be square root of that 221, okay? All right, so then we actually want to compute the actual integral, but before we have to set it up. Of course, the limits will be 0 to 5. Everybody understands that. Now, instead of x squared, we're going to square the first component of the r vector, right? So this will become 7 squared cosine squared 2t. Then plus square the second component, y squared becomes 7 squared sine squared 2t. And then it's plus z, so z is 5t. And remember that ds wasn't just dt, it was square root of that, whatever that 221 dt. And so we are almost done here, except we are going to do exact same trick that we did when we were simplifying ds, and that is notice that 7 squared can be pulled out, and then in parentheses I will get cosine squared plus sine squared, and of course everybody already knows that that is just 1. So this is equal to 1, and then I still have 5t, and then the whole thing is multiplied by 221. Okay, so what is 7 squared? That's 49. So this will become 49 plus 5t. And then that square root, we just have to carry that along. Okay, the last step is to actually compute this integral, which is a piece of cake because, okay, so let me just not forget that square root. So integral of 49 would be 49t. Integral of 5t will become 5 halves t squared. So remember, we add 1 to the power, and then we just substitute 0 and 5. Okay, so let's just substitute 5 in there. So it'd be 49 times 5 plus 5 halves times 25. Okay, so whatever that is, I got 615 over 2. So I think that that would be the answer here. And don't forget the square root. That's it.